Okay, so what are we looking at today then, guys?
Map and forEach.
Map and forEach, anything else?
Reduce.
And reduce as well, yep. So what are they? They're 3 array methods. Yeah, very, very useful utility functions, and we'll find out how and when to use each one, and let's see what we prefer. So can everyone see that screen? It's very bright again, isn't it? Not that one. Picture, yep. It's a little bit better. That first one, I think. That one? Yeah. Excellent. So, let me just zoom in slightly. So I've prepared a little snippet here. So can anyone tell me what this function should do? So this function here called what? Gower, can you run me through it? So the function is called double, so what do we think it should do? Yeah, so we've got a sample array down here of some numbers, 1, 2 and 3, and we want to write a function to just double those numbers. Yeah, so we're looking for the output of 2, 4 and 6. Using forEach, like this, what will we return? And there's definitely at least one bullet point for a correct answer. Yeah, so that was Pelin, yeah? Said an array or an object or what?
The input.
What will the function return? 2, 4, 6. Okay. Everyone agree? Anyone disagree? Lucia, Wendy? Agree? Camille? Agree? That will return just double of our original array that we passed in? Yeah? Okay. I'm going to run it and see what happens. Undefined. Whoa. What's going on there? Why did that return undefined? Let's try and break it down a little bit. I think we definitely missed something, but what forEach should do is it should iterate over each element in the array and perform a function on it. Yeah, and our function we've defined here as take the array element and times it by 2. Seems alright. So if we do console log that, just so we can get a bit of feedback in the console. Just the one, yeah. Luigi, are you there? I heard a little click then. Yeah, you're there. Okay, great. I can hear you. So we've just started. We're just explaining this function, and everyone said it would return 2, 4, and 6, and instead it returned undefined, and we're trying to work out why at this stage. Okay. So if I run that now, we can see that our console log is actually returning values of a 2 for the first iteration, then a 4 for the second iteration, and a 6 for the third. So the logic seems to be working, but it's still eventually returning undefined down here.
Because you are now returning.
We're returning here, right? Returning here.
No.
No, you want to return?
In the return R.
Okay.
Did you return there?
Return all this?
Yes.
Yeah? We can delete the brackets now if you want. Okay. I run that. Let me clear my console so we can see. Still undefined.
No, there's a Okay, you're not assembling the results into. Am I wrong? Because I don't see where you would assemble. You're mutating existing array. Are you?
Yeah, so we'll talk a little bit more in detail about what forEach does, but the first key thing to note about forEach is it always returns undefined. Its return value is undefined. Okay, so you wouldn't return something involving forEach. What you would do is you'd perform the forEach method, and then that is a mutator method, which I think was what Vilius is getting at. So that can, well, that can mutate the array. This inner part here can mutate the array. So if we wanted to return our array, we can just do that at the end. Let's see, just check my syntax.
Now looks fine.
And now we're getting 2, 4, and 6.
Because with return at the beginning, we go out from the lesson, no? Breaks the.
I mean, return is returning the result here of the forEach method, but if you look at the documentation of forEach, then is this the one? Yep. Then
So basically, what it does
return
for
value undefined. Whoops. Yeah.
By
So
default.
by default, always, no matter what you put in as the function, it always returns undefined.
It overwrites your function, your actual array.
Well, that depends on what function you pass into it, but in this case,
in that case, it
then
overrides.
we're taking each index of the array and multiplying it by 2. And array is the original array, yeah? So we're mutating it.
It's overwriting it.
It's overwriting it, yeah. So 1
It's
has
not like
become
map.
2. It's not like map. No, no, no. So we'll talk about the differences very, very soon. Yeah.
I have a question actually. So let's say, so forEach function itself is like a void in a different language. So it's not so, it does a job.
Let's stick to JavaScript, I think, Vilius, just to avoid confusing the matter. Yeah.
Okay.
Yeah.
So the question.
Yeah. Cool.
Does that mean that the two returns on top are completely pointless, right?
Yep.
This one is pointless and that one is pointless as well.
Yep. Absolutely. Because we want to return the array after we've performed forEach on it. Yeah, so just be careful when using forEach, because it will never return anything. It will return undefined.
So
Yeah.
even if we declare a new variable, for example, like new array, and then return new array equal array forEach, in that case, all will be the same.
Yes.
Without putting the return array in there.
So if we wanted to keep a copy of the original array, then we'd have to do something like that. Yeah. How do we create a copy of an array? Array with the 3 dots.
Spread.
So we could use the spread operator. Yeah. And then we can perform forEach on our copy. And if we returned array now, what would it be? The original array, right?
Yeah.
1, 2, 3. Yeah. So we want to return our copy in this case if we're doing the double function, and we get 2, 4, 6. Yeah. Happy with that?
I have a question.
Yep.
If the copy index is the first element, for example, the first iteration, then we say forEach,
Mm-hmm.
the copy index on line 5, if it's 1, why do we need a numerical? Can we not multiply it afterwards?
Why do we need, what are you saying? Why do we need
Non-variable.
here?
Yeah.
So you were saying just put copy index again.
Or just times 2.
So so do something like that.
Yeah. That way.
Oops, I put my breakpoint now. So we've got an index value of 0, yeah, and then we're saying reassigning that multiplied by 2. Should work in theory, right? Let's just Skip. Sorry, let me remove that just so it's clearer. Go back to here. Yep, so that works as well. Yeah. But I think that's a little bit less readable if you're not super familiar with JavaScript than what we had before. Yeah, which is just that. Okay. All right, now Walter mentioned map. Can we go on to it? One more question?
What if instead of copy in this case, you put const? Instead of let, the copy when you
Const?
Yeah, const. What will happen?
You
Will
can,
it return?
Doesn't change anything in this case.
if
But that's return type error.
it won't allow you to mutate. Constant and let they're inherently different.
I think we'll talk about let constant var in another lecture next week because it's a little bit confused. It's not quite intuitive in this case. But yeah, let's move on to map because I want to spend about 10 minutes on each, and we've already done 10 minutes on forEach. Okay, so map still iterates over each element in the array, yeah, but it returns something. Okay, so usually this is an easier way to write something like this. So can anyone help me out? Suleiman, how you doing down there? You want to help me write this double function? So we want the same result, 2, 4 and 6, but this time we're going to try and use map. Just let Suleiman have a go first and then I'll come to you.
So,
No idea, Suleiman?
Now I'm a bit confused because before you said that in the forEach the return function doesn't define.
Yep.
And map is similar, so I'm not
It's
sure.
similar, but it does return a value. Yeah, it returns an array of the same length as the original array. And what we pass into map is our transform function, if you like. What do we want to do to each element in the array?
can I?
Let's go with Pelin. Huh?
You're just creating a new array.
It will return a new array. Yep. So it's not mutating the original array.
It doesn't affect the sample number.
Nope. Sample numbers will remain the same. So let's go to Pelin. I think Pelin had a suggestion.
So inside the function, so inside here, num arrow function.
Yep.
Num again.
Num again.
Multiplied by 2.
Multiplied by 2. Yep. Nice. Parentheses where here?
The first one.
The first num. So like that, is you're saying? Or yep. Do we need those guys?
No.
There's only one argument, so
Exactly. We don't need those because there's only one element. If we had a second element, we'd need them, right? But in this case, there's only one argument in our arrow function, so we don't need the brackets. Okay. Does that look a bit more readable than forEach? I think so, definitely. Yeah, so that will support functional programming really nicely. It's very readable. We can understand pretty well what that does. So number is our element at each iteration, and we're multiplying that number by 2. It's fairly self-explanatory, yeah?
So may I ask you something?
And let me just check it works.
Yeah.
And we still get 2, 4, 6. Okay, yep. Pelin, go ahead.
So
Question?
it's not mutating the array, it's create a new array.
Yep, so if we returned array itself, and I got rid of this return statement, what's the value of array going to be? So that's the original one that we passed into the double function here.
1, 2, 3.
1, 2, 3, right? Should be. Yep, 1, 2, 3.
Alright.
So it's not mutating that original one that we passed in. It's creating its own copy. If you want, we can say let new array, yeah, equal that, and then we can return new array. Yeah, and that would also work. So that's definitely the simplest. I just want to check that we understand our syntax. So if I drop that down onto a line, new line, what do I need here? Yep. So let's stick everything within. Anything else needed?
Yeah,
Close it off. Anything else? And we need a return as well, right? Cool. Nice, and that would also work. Alright, so in general, map's the one to go for. And just a quick little note as well. This one. Yeah, in general, map is also more performant than forEach. Yeah, so this is just a test that someone ran on JS Performance, JS Perf. And you can see that, you know, we're getting, well, forEach was nearly 70% slower than map in this case. I mean, be a bit careful with these tests because it does vary depending on what data you've got. But in general, map will also be more performant than forEach.
Can I add something?
Yeah, definitely.
So I really like this slide, that view, because when you go to a job interview, right, you expect employer first. What's the difference between map and forEach? You know that already, right? The employer knows that you know that, you explain, blah, blah, next question. However, if on top of it explain the difference, you talk about performance, this is completely unexpected. No one talks about performance, pretty much almost nobody talks about performance. So if after the explanation you share that you have to give exact numbers into that. Map, another advantage of map is way more performant than forEach, and probably with the food. He or she really knows what he's talking or she's talking about. Okay? So that's a good thing.
Cool. And let's move on to our, unless there's any more questions, let's move on to our third method of the day. I know it's a bit of a whistle-stop tour, but we'll definitely get more in depth to these functions, especially reduce as we look at the expert challenges. And yeah, so sometimes I think it's easier to understand reduce if we're just returning a single value, such as a sum or an average. And this is probably how you'll initially see it. Maybe to calculate the sum. You might have already done that. Does anyone know what arguments reduce takes? A thing called an accumulator, yeah?
Yeah, accumulator.
So I'm just going to call it ACC for now, for accumulator. We can change it maybe to make it more readable and better semantics later, but let's call it accumulator. Anything else?
Another one, I don't remember the name.
Don't remember the name, but it's the same as map and forEach, right? It takes each element in the array that it's being called on. So I'll call it element for now. Yeah, or let's call it, we can call this one num again, right? It's going to take each number in the array. Let me just give us a bit more room because I've zoomed in. If I zoom out, can people still read that? Just about the back? Or you've got it on YouTube if not. Okay, so we've still got our same sample numbers there, but this time we want to return the sum. How would we do that?
So,
Yeah, but let's go for it.
Yeah, accumulator plus.
Accumulator
plus equals.
Plus equals, yeah.
Yeah, shorthand and number.
Number.
Num.
Yeah, okay.
And reducer. Is reducer a function? It's returning its value.
Yep.
So
Reduce will return the accumulator
Yes.
on the last iteration as
Yeah,
its
so
final return value. Yeah. So we're happy with that.
Should be fine.
Anyone else? Any amendments to that, or shall I run it and we think we're happy with that. What value are we expecting first? The sum of these elements?
6.
6, yeah? So we're expecting the value 6. That's what we want to return.
Don't we need to add return statement?
What line, Villius?
I can't see.
Can't see.
Well, it's like
So we've got return here. Do you mean below? Yeah.
One below.
So do we need this return statement here, guys?
Yeah, because there are different.
Yeah. We definitely do. Otherwise, the value of the accumulator on each iteration won't be defined. Yeah. We can add some breakpoints in a second and run through it. But for now, let's just see whether this is working. Oh. Have I written another function down here? Everyone, close your eyes and look away now. Okay, so I think we're running my double function down here. So, how do I do it without showing you? Very quickly. That's what I'm trying to think of how to do it. Alright, that's our challenge in a second. I didn't realise I'd left it there. My mistake, apologies. Okay, so now that works. We're returning 6. Fantastic. What happens? What have I done there? Adding a comma and a second argument that is effectively to the reduce function. So what is that
Where
doing?
to start?
starting from.
Later it's going to be 0.
So you're saying the accumulator is 0. When is the accumulator 0 in that case?
At the beginning first.
When you make the function first, then you go to 0 plus 1 and then it's going to
Okay. Will that affect the result?
Yeah.
So what value will it return now?
So it's still 6
Still 6. So it won't affect the result then,
because it's 0.
because it's 0.
Yeah, otherwise maybe the function maybe that index is 0 and that's
Okay. So let's step through it bit by bit, and we'll explain it as we go along. So I've added a breakpoint on line 8. It's annoying that it's popped up straight away. I should have asked you beforehand. Okay, so we can see that the value of the accumulator on iteration 1 was 0. And the value of the number on iteration 1 was 1. Okay, so based on that information, on iteration 2 of our reduce function, what is going to be the value of the accumulator?
1.
Everyone agree?
Yeah. Or
3
So on iteration 1 or 2?
on iteration.
First.
So this is the first iteration. So iteration 2, let's say. Second iteration.
3.
Okay. How do you get 3?
No, sorry. Accumulator itself is 1, and the number it's adding in the second iteration is 2.
Nice.
So the total is 3.
Yep. So let's step through and see whether who gets right. So on the second iteration, you can see our accumulator is the result of this from the first iteration. So we had 0 plus 1. So that means the accumulator for the next iteration is the result of that. We're returning that as a callback, which keeps going through the function. And then this time we're adding on the second element. So on the next iteration, what will the value of the accumulator be? We've got a 1 and we're adding on a 2. So it will be, yeah, everyone shout it out, 3, right? So we can see 3, num will be 3, and then on the last iteration, we get our 6. Alright. Any questions on that before I challenge you to write the double function using reduce?
So can we add 0 at the end of the function? Do we need? Because the result...
No, in this case we don't need it, but this initial value can be very, very useful sometimes.
Right, 0 marks a point of element. It starts or finish.
Yeah, this is the
Starting.
This is the starting value of the accumulator. So, if I did a value of 5 here,
So it will start at 5, accumulate.
and we step through again, what's the value going to be of accumulator, and what's the value going to be of number? Yep, so save it. If we run that, you can now see the accumulator's 5, and the number's 1. Next step. 6, 2. Next step. 8, 3. And then that gives us a final result of 11, which is 6 plus 5. Boom. Yeah? So don't do that in this case, but you can see how it could be useful for other functions. So in this case, we can just leave it off. Right, last challenge of this workshop. Can we rewrite the double function from earlier? So let's just get this from here. Using reduce. I'm not saying it's the easiest way to do it, but it will help us understand reduce. Double da da da. Okay. Anyone want to start me off? Board challenge points available for 4 for a correct answer. What's that?
If the result you're expecting
Yep.
is it an array with every number doubled, and we need to use the map as well. We can't do it just by
No, we don't need to use map. Let's do it just by reduce. And we want to return 2, 4, and 6, the same as before.
Okay.
An array of 2, 4, and 6.
Array of 2, 4, and 6.
Yes. Using reduce. So what are arguments first? What does it always need?
But you want to return an array.
I want to return an array, yeah? With the 3 numbers in it. Exactly the same as before, exactly the same as map. So we always need an accumulator, right? And we're going to be doing something with the elements, which we'll call nums. Num, singular, just one of them, isn't it? Anything wrong so far?
Then after that,
Yeah, we've got 2 arguments, so let's have some brackets for our arrow function. And I assume we want to return something.
return, accumulate, multiply. No.
equals,
Equals, someone said, Suleiman?
yeah, to
Any ideas, Luigi?
Can we say accumulator equals?
It's gone for a cup of tea.
Sorry.
Yep.
Can we say accumulator equals num multiply 2?
Say again. Accumulator equals
Yeah.
like that.
Num.
Doubles equal.
Yeah.
Num.
Num
Yeah.
multiply 2.
Multiplied by 2.
It's
So what's that going to evaluate to, that bit, guys? It's a comparison, isn't it?
Yeah.
So we're going to get a boolean out of that. True or false, yeah? So I don't think we want to return true or false. So we had that to begin with. No?
Can we actually, I'm thinking, accumulator push.
Accumulator push.
Accumulator push on close num by 2. Thank you.
So Vilius has suggested something like that.
I mean, accumulator, is it defined, it should be number, but if it can be an array, it still goes for every.
So what is the accumulator at the moment?
Accumulator is nothing.
We don't know.
So
There is nothing. So if I define as a push, it should create an array.
An empty array, for example.
You want to start with
let's just be clear on what the accumulator is first, guys. So people are saying it's nothing, which is not strictly true. I know we haven't put a second argument here for the accumulator, but when we don't put that second argument, on the first iteration, does anyone know what the accumulator becomes? What value it becomes? It's not 0. It's not 0.
NaN?
Not NaN. Not 1 either. Well, oh, hold on. 1. Is that 1 in this case or 1 always? Is it always 1, Luigi?
No, it's the first element of the array.
Aha, so it's the first element, Luigi said. It's the first element. Yeah? So that's what it becomes. So if this was a 3 in here, on the first iteration, the accumulator would be this value here. Yeah? Or we can set it ourselves.
Why don't you set it as an empty array?
Oh, I like that. I like that. Why don't we set it as an empty array? So we've definitely had Vilius, Luigi, and Nico to contribute to part of this. So you all work together, which is nice.
Okay.
Will this work as it is? Should we add a breakpoint here and see what's going on? If I can, let me save it again first. Hands up for yes, hands up for no. So will it work? Yes.
Should be.
So no one's very confident.
Okay, first.
Okay, so we've got our accumulator is an empty array. Our number is 1. Stepping over, our accumulator is 1. Yeah, so it's not quite what we wanted, is it? Because we wanted an array. So why is that not working? Accumulator.push is not a function, so it seems
It's no.
our accumulator is not becoming an empty array.
Can it be defined like when you create an array, you can like tell like I want a like 3 elements array. Or still.
So let's have a look again at that first iteration, shall we? Oh, what's going on now? Have I lost my breakpoint? Is that a DevTools thing, Ricardo? Or?
Yeah, so
Yeah.
you close the tab. Win incognito.
Yeah. So close that one.
Yeah, training tab or something like that. Yeah. Incognito tab.
Yeah. Da da da. Sorry. Okay.
Can we use as an accumulator an array which is identical to the one we want to double? Would that work?
Don't think we need to do that, Luigi.
No?
No. Okay, so our accumulator is being initialized to an empty array. Okay, so that bit is working, but then what are we trying to do?
push.
So what do we expect our accumulator to be on the next iteration? We expect it to be an array with 2 inside, right? But that's not happening. Oh, 1. Yeah? So something weird's going on there. So how do we fix that?
We can create a new array inside and then push the result into the new array, not using accumulator.
So accumulator equals.
So we've still got, yeah? Struggled to spot it myself now, we've moved around so many times.
So accumulator equals the same thing.
We use the one. So what is push returning?
But it's push returning.
Yeah.
But we're getting an error, aren't we?
So push is one of the classic JavaScript methods.
The array
And
methods.
API is horrible. Yeah? Because push, you may expect it to return an array with the new array, with the new length and everything. However, this is not the way push works.
No. It returns the element that it...
It returns the size of the new array.
Oh,
which
yeah.
is completely bullshit. Yeah?
It returns the size of the new array, yes.
Unusual. That's why in the first iteration, accumulator is correct, it's an empty array, fair enough. But then, because we're returning array of push, it returns the length of the array. What's the length of the array after pushing the first element?
1.
1, correct.
That's what we got.
Number 2, yes. So that's why we need to do it. There are 2 ways to do that, in 2 steps. First of all, add the element, and then you can return the accumulator safely. Yeah?
And now it's not even running. It's DevTools again, right?
That's a little thing, but that's correct. And
Yeah,
at the
that's
bottom
good.
will cause problems. You've got Davies and someone else in there.
Oh, yeah.
You need to close the tab again.
Yeah.
Yeah, that's one
Okay.
thing. There's nothing you can do.
Okay. Nope, come on. This one. Let's get rid of everything else. Okay. There we go, finally.
Cool.
Yep, so obviously not the easiest way to do it, but just be aware that you can initialize your accumulator to something other than the first element in the array, or the first element, or it can be a different data type. We could initialize an empty object, whatever we want our return value to be, really. So reduce is incredibly powerful, and you'll find that you can do with reduce what you can do with most other helper methods. But map's obviously more specific and more suitable in this case, right? Because we just had to write that. It's a lot simpler. And so if we want to return an array with the same number of elements as the original array, but transformed in some way, then map is definitely the way to go. Yeah. Yep.
When using push, map reduce, please.
Yes.
So you see that push is a bit tricky, right? Because it doesn't return what we expect. However, does anyone know how to add elements to arrays in modern JavaScript in a simple way? There's a new method to replace push to solve this problem. No. No. Start with C.
So the question was, Luigi, how do we add elements to an array in modern JavaScript? Because of the problems with push, there's another method that begins with C that we could use instead.
Concat is not for arrays.
It's not for array. Why is it for then?
I mean for concatenating more arrays.
But you can add elements to an array using concat. And the beautifulness about concat is literally that. You see, you get the both things of push. First of all, you can add elements to the array.
So we had that before.
Yeah, and then you can return the new array immediately, right? That's why it's a bit simpler.
So this time, still returns 2, 4, and 6. Okay, because concat's returning the amended array straight away. Yeah?
You can also pass like 2 arrays.
Yeah, of course. Concat is way more powerful than push. That's another classic job interview, right? Differences between push and concat. So you can explain all these things we've been talking about, and there is one reason not to use concat. Back to performance. Because concat is way more powerful than push. It also comes with a penalty. It's much slower. If you want to add 20 elements to the array, that's fine. But if you want to add all the news about the Brexit, it will blow up your browser. Yeah? Be careful with that.
Okay, we've gone way over time anyway trying to solve that, so should we leave it there? Yeah? Cool, thanks guys. But if you want those snippets, I can post them on Slack and you can play around yourself with them. Yeah, I've got a few nods, so I'll definitely do that. All right, nice. Thanks.